You think the speed of light is a fact, and number 299,792,458 meters per second, the ultimate speed limit. You file it away in your mind alongside other facts, the boiling point of water, the height of Mount Everest. But this is not a fact like those. This number is not a measurement of something in the world. It is a measurement of the world itself. It is not a property of light. Light is merely a messenger that reveals it. To ask why you cannot go faster than light is to ask why you cannot find a corner in a circle. It is to ask why you cannot be more north than the North Pole. The question misunderstands the territory. The speed of light is not a limit within space-time. It is the structural geometry of space-time. To see this, we must begin far from light, in the realm of force and motion, and walk a path of revelation that will bend your intuition until it breaks and reforms into something new. Let you start with the most common observation in human history. Things fall. Release an object. It accelerates toward the ground. In the first second, it falls 16 feet. This was Galileo's great insight that all objects, regardless of mass, fall at the same rate in a vacuum. But why? What invisible hand pulls them? For centuries, this was simply how the world worked. Then came Isaac Newton. He looked beyond the apple to the moon, hanging in the night sky, and he asked a revolutionary question. Is the force that pulls the apple the same force that holds the moon in its orbit? To answer this, he performed a calculation of breathtaking audacity. Consider the numbers. The moon is approximately 240,000 miles from the center of the Earth. We stand on the surface, about 4,000 miles from the center. The moon is 60 times farther away. Newton proposed his law of universal gravitation. The force of attraction diminishes with the square of the distance. If you are twice as far, the force is 4 times weaker, 3 times as far, 9 times weaker. Therefore, at the moon's distance, gravity should be 60 squared, or 3,600 times weaker, than at Earth's surface. Now, an object at Earth's surface falls 16 feet in the first second. If gravity is 3,600 times weaker at the moon, then an object there should fall only 16 divided by 3,600 feet in 1 second, a minuscule distance. Newton then asked, the moon is not stationary. It is moving sideways in its orbit. How far does it actually fall toward Earth in 1 second as it curves along its path? He calculated the curvature of its orbit. The result, that same minuscule distance, a perfect match. The moon is falling continuously. It is falling round the Earth. Its forward motion perfectly balanced against its gravitational fall, so that it never hits. The same force governs the apple and the moon. This was the first great unification. Celestial and terrestrial mechanics were one. From this law, Newton could derive the elliptical orbits of planets, explaining Kepler's empirical laws. He could explain the tides not as one bulge of water toward the moon, but as two, one where water is pulled more strongly than Earth, one where Earth is pulled away from the water. The roundness of planets, their obliqueness due to spin all, flowed from this inverse square attraction. The universe seemed rational, mechanical, clockwork. As science advanced, the tests grew more precise. In the late 1600s, astronomers like Reimer studied the orbits of Jupiter's moons with meticulous care. They found a disturbing anomaly. The moons did not appear at their predicted times. Sometimes they were 8 minutes early, sometimes 8 minutes late. The error was systematic. Early when Jupiter was closer to Earth, late when it was farther. Too many. This might have suggested a flaw in Newton's elegant law, but Reimer had faith in its coherence. He proposed a radical idea. What if light is not instantaneous? What if it has a finite, though immense, speed, then the light from the moons takes time to reach us. When Jupiter is nearer, the travel time is less, so we see the event earlier than expected. When Jupiter is farther, the travel time is longer, so we see it later. By quantifying this 8-minute discrepancy and knowing the changing distance between Earth and Jupiter, Reimer calculated the speed of light. He was the first to demonstrate it was finite. Pause here. This moment is critical. We did not discover the speed of light by chasing a beam with a stopwatch. We discovered it through a failure, a discrepancy in the motion of distant moons, resolved by unwavering confidence in a law of gravity. The speed of light emerged as a necessary truth to preserve a deeper truth. This is the engine of science, anomaly leading to insight. Insight becoming a tool for a deeper exploration. Now, we know light has a speed. We measure it with ever greater precision, and here, the true strangeness begins. In the late 19th century, physicists sought to understand light as a wave in a medium, the luminiferous ether. They reasoned that if Earth moves through this ether, the speed of light measured on Earth should depend on our direction of motion. Just as a swimmer's speed relative to the water depends on the current, the famous Michelson-Morley experiment of 1887 sought to detect this effect. They split a beam of light, sent it in perpendicular directions, reflected it back, and looked for an interference pattern that would shift as Earth changed its direction through the supposed ether. The result was a profound, unsettling null. No shift, no ether wind. The speed of light was the same in every direction, regardless of Earth's motion. It was as if the universe had declared, the speed of light is absolute. This was the crisis. The bedrock principle of Galilean relativity that velocity is shattered when applied to light. If you are on a train moving at half the speed of light and you turn on a headlight, common sense says the light should rush ahead at 1.5 times light speed, but experiment said no. It moves at exactly light speed. For you, for someone. Standing on the tracks, for anyone, anywhere, in any state of motion, the measurement yields the same number. How can this be? Albert Einstein, in 1905, confronted this paradox with breathtaking clarity. He elevated the constancy of the speed of light to a postulate, a fundamental principle. He then followed its logical consequences. No matter how absurd they seemed, if the speed of light is constant for all observers, then the measurements of space and time must change for observers in relative motion. There is no other way. Imagine a simple thought experiment. You are standing next to a light clock or box with a photon bouncing vertically between two mirrors. You see the photon go straight up and down, tick, tock. Now, imagine this clock moves past you at near light speed. From your perspective, the photon now takes a zigzag path. It goes up and down, but also moves horizontally with the clock. This path is longer than the vertical path. Since the speed of light is fixed, a longer path means more time. Therefore, the moving clock ticks slow from your perspective. Time itself has dilated. This is not a mechanical defect. It is time, and it works both ways. From the perspective of someone moving with the clock, your clock is ticking slow, simultaneously. Lengths contract. An object moving relative to you appears shorter in its direction of motion. This, too, is not an illusion. Space itself is compressed. These effects, time dilation and length contraction, are the universe's precise mathematical adjustment to keep the speed of light constant for everyone. They are negligible at everyday speeds but become dominant. As you approach light speed, at 87% of light speed, time slows to half. At 99.5%, it slows to 1/10. At 99.9999%, A single second for the traveler is over 700 seconds for a stationary observer. Asterisk now we approach the heart of the limit. Why can't you go faster? Let's follow the mathematics of relativity. An object's energy is given by a famous equation, E equals mc, where gamma the Lorentz factor is 1, square root 1, v squared per c squared. Look at that denominator, square root 1, v squared per c squared. As your velocity v approaches the speed of light c approaches 1, v squared per c squared approaches 0. The square root of a number approaching 0 also approaches 0. Dividing by a number approaching 0 makes gamma, the factor, approach infinity. Therefore, the kinetic energy required to accelerate you further approaches infinity. Asterisk to reach exactly c would require infinite energy. The universe contains no infinite energy source. Hence, for any object with mass, c is an asymptotic limit. You can approach it arbitrarily closely, but never touch it. Asterisk, but this is more than an energy problem. It is a problem of causality and identity. The Lorentz factor doesn't just blow up, it becomes imaginary if v exceeds c. The mathematics yield square roots of negative numbers. In physics, this often signals a passage into a domain where concepts like proper time and mass become nonsensical. More profoundly, if you could travel faster than light, there would exist reference frames in which you arrive before you leave. You could send a signal into your own past. Causality, the logical sequence of cause and effect, would unravel. Paradoxes like killing your own grandfather would become possible. The universe seems to have a foundational aversion to such paradoxes. The speed of light is the speed of causality. It is the maximum speed at which information, influence, or any physical effect can propagate. Asterisk, let's visualize space-time to understand this deeply. You are always moving through a four-dimensional continuum. Space-time. Your total velocity through space-time is constant and it is exactly c, the speed of light. This is a profound shift in perspective. You are not sitting still in time. You are a traveler, and your fixed speed is c. This velocity vector, however, can be pointed in different directions within space-time. If you are stationary in space, your entire velocity is directed through the time dimension. You move into the future at the maximum rate, 1 second per second. The moment you begin moving through space, you must tilt your velocity vector. Some of your fixed speed through space-time is now allocated to motion through space. Consequently, less is allocated to motion through time. Your clock ticks slow relative to someone stationary. If you could allocate all of your space-time velocity to space, tilt the vector completely into the spatial dimensions, you would move at speed c through space, and your motion through time would be 0. Time would stop for you. This is the condition of light. A photon experiences no passage of time. Its emission and absorption are, from its perspective, simultaneous events. There is no faster than this, because you cannot tilt the vector. Further, you cannot have negative progression through time without violating causality itself. The limit is geometric, woven into the Pythagorean theorem of four-dimensional space-time. Asterisk, this is not speculative philosophy. It is tested with relentless precision. Particle accelerators are monumental testaments to this limit. In the Large Hadron Collider, protons are accelerated to 99.9999991% of c. Their Lorentz factor gamma is about 7,000. This means their mass energy is 7,000 times their rest mass. The energy required for that final 0.0009% of c is colossal, far more than was needed to get them to 99% of c. They press against the asymptotic wall every moment. Asterisk, cosmic rays provide a natural laboratory. Muons, created high in the atmosphere, have a half-life of 2.2 microseconds. Even moving at near c, Newtonian physics would dictate they decay long before reaching the ground. But we detect them in abundance at sea level. Why? From our perspective, time dilation stretches their lifetime. From their perspective, length contraction shrinks the atmosphere, allowing them to traverse it before decaying. Both descriptions are valid, both required by relativity, both confirmed by observation. Our global positioning system is a daily, practical proof. GPS satellites move at about 14,000 kilometers per hour relative to the ground. According to special relativity, their onboard clocks should tick slower by about 7 microseconds per day compared to ground clocks. However, they are also farther from Earth's mass in a weaker gravitational field. According to general relativity, the extension of these ideas to gravity, clocks at higher altitude tick faster. This effect is about 45 microseconds per day. The net result is that satellite clocks gain about 38 microseconds per day relative to ground clocks. If this were not corrected, GPS would accumulate errors of over 10 kilometers per day. The system would be useless. Engineers must deliberately build this relativistic correction into the system. Your phone's navigation depends on Einstein's theory of relativity. So, the limit is real, physical, and woven into the operational fabric of our technology. But let's go further. Why this number? 299,792,458 meters per second. It appears arbitrary. But it is not fundamental in itself. It is a conversion factor. It converts between units of space and units of time, which we humans define separately. In the deeper, natural units used by physicists like Planck units, the speed of light is simply 1. It is the fundamental scale. What is truly fundamental is the structure of space-time that gives this conversion its value. Some theories suggest that this structure may have emerged from a more fundamental quantum foam in the early universe. But within our classical, smooth space-time, C is a constant feature of the geometry. Finally, consider the grand narrative from Newton's unification of heaven and earth, to Riemer's inference of light's finite speed from celestial mechanics, to Michelson and Morley's baffling no result, to Einstein's radical reimagining of space and time. This is a continuous chain of human reason confronting anomaly and building a more profound picture of reality. The speed of light is not the end of the story. It was the gateway to general relativity, where gravity is understood not as a force, but as the curvature of space-time itself. It was the gateway to quantum field theory, where particles are excitations in fields that obey the speed limit. It hints at a deeper quantum gravity, where space-time itself may be discrete. When you see the number 299,792,458, do not see a mere velocity. See the rigidity of causality. See the mutability of time. See the elasticity of space. See the unity of space and time into a single dynamic entity. See the ultimate regulator of information and influence in the cosmos. It is the universe's own protocol, ensuring that cause precedes effect, that history is coherent, that reality is logically consistent. The fact that we, collections of atoms evolved on a small planet, can deduce this structure not from revelation, but from observation, reason, and the courage to follow logic where it leads, even into realms that defy common sense, is perhaps the most astonishing thing of all. The speed of light is more than a limit. It is a teacher. It teaches us that the universe is not what it seems, that our intuitions are provincial, and that truth is often stranger, grander, and more beautiful than our untrained imaginations can conceive. And we are just beginning to listen.